Hello, everyone. My name is Agastya. I'm one of the co-founders of YouthSTEM, and I'm going to be talking about statistics with Excel. So part of every project that nearly everyone underestimates is the importance of analysis, and specifically data analysis. What this means is that once you collect a lot of data and tasks, anywhere from environmental studies to surveys to machine learning projects, you might find yourself staring at a bunch of numbers without a good idea of what to do or take away from it. Some of the questions you should then be asking, and some of the questions that Excel and statistics can help us answer then are, is there a correlation between some of my variables? Are my results significant? How do I easily interpret my data visually? All this is just as essential as a project itself in order to effectively communicate your results in science. Today, we're going to be looking at a lot of data from a call center. There's a Google Drive link in the description of the video. If you click on that, you should be able to download an Excel worksheet. All right, once you have the Excel open, what we're going to try to do is follow along as I'm going through these steps so that you can understand how to do it with a project of your own. So the first thing that's kind of striking about this is that there's a lot of data, like a lot, there's tens of thousands of rows. And what this is essentially data compiled from different calls that have been taken by a company from different customers that measures how they feel through their CSAT score, when the call happened, the reason, where they're from, etc. And it's a lot of data. It's incredibly hard to interpret because there's just so much of it. This is why it's incredibly important to know how to analyze that data to then make the most of it. So the first thing we're going to do in order to be able to do that is to check the data type. Something that should spring out at you is that most of this data is not numerical, but two parameters are the CSAT score and the call duration in minutes. We want to make sure that Excel recognizes these as numbers so that we can process them effectively in other tasks. So the easiest way to do this, go to the search bar, search number. There we go, number format, and let's format it as a number. And you can see that Excel now recognizes it as a number. I'm going to quickly do the other thing, the same thing for the other column. All right, so now we're going to see how we can represent all of this data visually in order to break it down and understand basic trends, because there's just so much data. We're going to do this through three methods: line charts, donut graphs, and maps. Before we get started, I'm going to introduce something called a pivot table. It's incredible in Excel because it allows you to automate a lot of the processes and make it really easy to make things like graphs of different varieties. So the easiest way to make a pivot table, you should hit Control or Command A, go to the Insert tab and click Pivot Table. You'll see all the data is highlighted and you want to put it in a new worksheet. All right, I'm going to move this here and I'm going to call it Graphs. Perfect. So what you're going to see is that the pivot table automatically sees all the fields, so the ID, the customer name, etc., all the columns that I introduced before, and is able to process all of them in order to streamline any graphing process. So the first thing we're going to do is to make a line graph. In order to do this, you're going to drag ID to values. You can just select it like that. And we're going to have that in relation to call duration in minutes. So what we're looking at right here is based on the ID of the user, how much time are they calling for? So it's essentially going to give us like a numerical kind of representation of where, when, the types of people who are calling internally for the company. In this case, in your project, it could offer some insights about where most of your data is coming from, user preferences, etc. But it's very useful in order to be able to graph things in an expedited way. So we can see the values and rows, and we can see all of that is compiled right here in this graph. So what we're going to do is that we're going to click Insert. You can see a bunch of charts here. We're going to choose the line one, and we're going to choose line with markers. What that ensures is that we're able to plot the line graph with different points at each value for the row label. So essentially, it gives us an optimized line graph, which you can then label and do whatever you want with it in order to analyze it yourself. Now, since we're going to be working with the pivot table quite a bit, we're going to copy this over to a different spreadsheet so that we don't lose our progress. So quickly open a different spreadsheet and copy. Perfecto. Now, we're going to slightly alter the pivot table. So right now we have the ID and the call duration. Instead, we're going to drag channel to rows. So let's unselect that. Let's put channel. All right, so what we can see is this is categorical data. There's only 4 sources, and it's compiling how many people are calling through who are receiving call center, responsive chatbots, emails, webs. How are they contacting us, essentially? So this is important because it teaches us how to best deal with categorical data. A line graph isn't ideal for this because it's just points and it's not really telling you much about user demographics in a visually appealing way. What we're going to use is going to be the donut graph, which is one of my personal favorites. So we can click on this. We can change chart type. We can go to pie. We can click donut. And there we go. We can see a very visually appealing representation of this that allows us to essentially see call centers giving us the most. So in a project, for example, that you're working on, if there were multiple categories, this would make it easy to effectively communicate that this category is receiving the most attention or the most accuracy, etc., or whatever it is that you're analyzing. The last thing we're going to be doing is the map. This is one of my also personal favorites with Excel. So what we're going to have to do is that we're going to put in the state for rows instead of channel because it's a map. So let's drag state here. All right, so it tries to make this type of chart, but obviously this isn't very informative because we want to see a map. So how do we do that? Unfortunately, pivot tables are a little bit constrained in terms of maps, but we do have a solution. We're going to do Control A. Let's get this out of the way. All right, and we're going to paste only the values so that it doesn't paste as a pivot table again. And now we're going to click Insert and Maps, Filled Map. And there we see it. We can see different shades for a United States map based on frequency of ID. So we can see Texas and California, kind of Florida, are where we're seeing more engagement with the service. That's another nice feature of Excel if you're dealing with geographic data, climate change data, especially. This can be something really valuable in order to sort through and process that in a very visually appealing way. Now we're able to see what visually our data means, trends in the data, how it looks, where we're getting the most attention, but we still need a statistical, reliable way to demonstrate some level of significance or correlation in our data in order to get more insights. The first question we're going to ask is there a correlation between CSAT score? Remember, CSAT corresponds to customer satisfaction, it's the customer satisfaction index, and call time. Essentially, if people call for longer, are they left more satisfied? Now, what we're going to do is that we're going to create a new kind of spreadsheet here, except you can just press plus, and we're copying our data. This is because we don't want to modify our original data. But I'm going to show you a way to do this in a relatively easy way. Essentially, I said we want to look at the correlation between CSAT score and call duration, but you can see there's many values for which there isn't a CSAT score that wasn't collected. So we want to refine only the values in which we received a CSAT score. So in order to do that, what we're going to have to do is go to Data. There we go. And click Auto Filter. So, all right, so you can see a bunch of arrows. In terms of CSAT score, we want all the numerical data points, but we don't want blanks. Boom, there we go. So now all the blank values are taken out, so we can accurately analyze the correlation between CSAT score and call duration. So the way to do this is we type equals oral. All right, and now we have D2 all the way down to, let's see how far data goes. All the way down to D, or this would be easier. Excuse me, let's D that. There we go. All right, so that is our data. And conversely, for the other data point, the call duration, that's going to be the K column. So it's K2 all the way to K, 3, 2, 9, 4, 1. There we go. All right, so we're able to see a correlation coefficient. Now, all you need to know right now about the correlation coefficient is that if we receive a value of more than 0.5, where the absolute value is more than 0.5, then we can deem that there is a significant correlation between two values. Right here, we can see the absolute value is 0.0099, etc., which is certainly less than 0.5. That means that there's not a significant correlation between CSAT score and call duration. This is incredibly important in, for example, machine learning tasks. If you're trying to see, is there a correlation between changing this variable and then does that impact performance, for example? That can apply to a vast variety of tasks, engineering tasks, climate change, etc. When you're doing any project, you want to know if you can tweak one variable and how much of an effect that exacts on the outcome. Here, we can see that there's not a significant effect on the outcome because there's the correlation coefficient is low. Now, we're going to go to the t-test side. What this is a statistical significance test. You should click the t-test window, or rather the t-test spreadsheet. All right, so the t-test. This is a slightly different data set. It's the CSAT score that we saw from before, but we have a new CSAT score. Essentially, this CSAT score displays customer satisfaction prior to the call. This CSAT score displays customer satisfaction after the call. So we're trying to see, does our algorithm change the way, not our algorithm, but the call change the way that people think about the product? Does it change the way people perceive the call center to a statistically significant extent? Why does this matter? It helps us determine in a statistic objective way whether our results are significant. So you can see how that would apply to nearly every sector of data analysis, because the entire point of this is seeing, did I do an improvement in XYZ system that improved a system to a statistically significant degree? Now, we have customer satisfaction before and after the call. You can use this in data, like I was talking before, that you might collect to see a change, if a change in what you've implemented causes a significant change inside the data. If you want to learn a little bit more about the back end of this, I'd encourage you to go check out the YouthSTEM's videos on standard deviation. They're really informative here. And there's several videos on the internet that explain the back end behind this. For now, I'm going to go over how to do this in Excel. So we're going to go to Data and Analysis Tools. Right now, I have Analysis Tool Pack enabled. Most people won't. So we can see what that looks like if you don't. There's nothing there. You add in the Analysis Tool Pack, and boom, you have data analysis. So this procedure makes it incredibly easy to carry out the t-test. You click data analysis. You click t-test, assuming equal variance. What this means is that we're assuming the variance is close enough. I'll explain that a little bit more a little bit later. Let's click OK. And now we want to know the range of variable 1. So it's A2 all the way down. Oops. There we go. All the way down to A. Oops, I didn't quite get the number, but let me scroll back down. A12272. There we go. And variable 2 range is going to be the same thing, but in terms of B. So B, 2, B, 1, 2, 2, 7, 2. All right, let's click OK. And we can see the Excel spits out a t-test for us. Now I'm going to explain a little bit of the back end behind this. You can see the means are relatively similar. So are the variances. This is why we assumed equal variance, because the variances are close enough for it to not make a pretty significant difference. But if you're carrying out a serious statistics project, you should look more into that in order to see if that significantly impacts your data. For now, we're going to look at the two-tailed estimate to see statistical significance on both sides. We're using an alpha value of 0.05. What does that mean? It means that essentially, if the value we see here is less than 0.05, we can deem the change in user preferences to be statistically significant. What that means is from before you had the call, there's a significant change in how the user perceives the company, the call center, etc., to after. So there's a significant change in data. Here we can see that the p-test yields 9.7 e to the negative 55. E stands for 10. So it's an incredibly small number, which means that it's definitely less than 0.05, and it is statistically significant. You can use this in a lot of data where you're trying to assess whether a change you are making to the system actually impacts the system to the degree that you expected statistically significantly. All right, that's going to be it for this video. We covered charts and statistics for data. I really hope this helps for refining your future projects and collecting data in the future. Please check out some of our other research and other videos for some fun experiments and science tips. Have a good day.